Hello, this problem reads a sphere is fired downwards into a medium with an initial speed of 27 meters per second. If it experiences a deceleration of a equal to minus 60, where t is in seconds, determine the distance traveled before it stops. This problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Benam. So before we start solving this particular problem, let's remind us of the three basic equations, kinematic basic equations for problems like this. We are dealing with rectilinear motion, and this is motion in a straight path or a straight line. Right, so what are the three basic equations? These are the three basic equations, three basic kinematic equations. Right, so here we go. We have the first one, which is velocity, instantaneous velocity, which is the time derivative of position. We have the second one, which is instantaneous acceleration, which is the time derivative of velocity. And then when we make dt subject of the formula for both equations and we equate them, then we have a derived equation, which is a ds equal to v dv. Okay. From the three equations, we are able to derive three more equations, and these equations are derived when the acceleration is constant and t is the initial boundary condition, t is equal to 0, and at this point we have s naught and v naught. These are our boundary conditions, and the derived equations are s is equal to s naught plus v naught times t plus half ac times t squared. Then we have v final is equal to v naught plus sc times t. Then finally we have v final squared is equal to v naught squared plus 2ac by s minus s naught. Alright. So having said this, let's get back to our problem. So we have a sphere that is fired downwards. Let's draw this. So imagine we have this sphere and it is fired downwards. Okay. It is fired downwards like so, right? And its initial speed, so say v naught. So this is the sphere. This is the sphere. And its initial velocity v naught is equal to 27 meters per second. And later on it experiences some deceleration of minus 6t meters per second squared. And we are being asked now to determine the distance traveled before it stops. So let me also make mention of this v naught is taking place at t naught equal to 0, right? Because we are being told that this is our initial speed and it's taking place when our t is equal to 0, right? So we are going to employ this particular equation, right? Because we are dealing with acceleration which is not constant, therefore we're going to go with the instantaneous part. So we'll go with that equation there. And therefore we'll have a equal to dv dt, and writing this equation, then we'll have a dt equal to dv, and when we integrate on both sides, here we'll have 0 to t, then here we'll have v naught to v. Okay, so we have a minus 6t integrating from 0 to t equal to v naught we said is 27 to v dv. Okay, set dt there. Sorry. Right, let me just move this a little bit somewhere there. Alright, there we go. So if we integrate on one side, on one end, then we are going to have a minus 3t squared, right, equal to this side we are going to have a v minus 27. Therefore, our v is just going to be equal to a 27 minus, or I'll say minus 3t squared plus 27. So since we've been told that we are supposed to determine the distance traveled before it stops, let's find the values of t when velocity is going to be equal to 0. Those are the values that we are going to use later on to determine the distance. Okay, so we have velocity equal to minus 3t squared plus 27. So when v is equal to 0, we can write this becomes 0 is equal to minus 3, or we can say just 3 then t squared minus 9, right? Is that so? Therefore, our t is just going to be equal to plus or minus 3, but of course we are going for the positive value, which is equal to 3. Okay, so this when t is equal to 3, we expect v equal to 0, right? So having said that, let's go now and let's apply this particular equation, this one, so that we find the equation for displacement. So we have v equal to ds dt, and writing this we can say v dt is equal to ds. We integrate on both sides. Of course, at this point we have 0, a 0 to t, a 0 to s, right? And then let's plug in the values there. What do we have? We have minus 3t squared plus 27 dt, integrating from 0 to t, and then we have 0 to s ds. If we integrate this, we are going to have s like so, and then this one becomes equal to minus t cubed plus 27 t. Okay, so we found already the value of t when v is going to be equal to 0, and when v is equal to 0, it means our sphere has come to a stop, right? Okay, right. So then s, what is s at t equal to 3? Let's plug it in there. So we have 3 minus 3 to the power 3, okay, plus 27 by 3. Of course, this gives us a 54. Okay, which is 54 what? 54 meters. So this is the distance when our sphere comes to stop in the given medium. So I hope this particular video was helpful. Let me just outline this. I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.